This is ENME 351 Lab 4 by Theodore Tagle. This Arduino code reads the resistance of the potentiometer and outputs it to the serial monitor to be converted into a voltage measurement by the VSA app. The first experimental frequency in exercise 1 is 75 Hz. Here we can see the various sample frequencies and how those which the Nyquist frequency is under 75 Hz experience aliasing. The next frequency is 100 Hz sampled at the various sampling frequencies. The bottom two higher sampling frequencies do not experience aliasing, while the top two do because their Nyquist frequency is below 100 Hz. Third is 215 Hz. Only the sampling frequency of 500 Hz does not display aliasing. Finally, the frequency of 300 Hz. All sampling frequencies have a Nyquist frequency less than 300 Hz, therefore all of them display aliasing. To calculate aliasing, we use a folding diagram and a ratio of how the frequency compares to the Nyquist frequency to get a proportion of the frequency that the alias represents. This table compares the theoretical aliasing frequency to the experimental aliasing frequency, and as you can see by the final two rows of each frequency, the theoretical and experimental values are nearly equal. Exercise 2 demonstrates a square wave with the frequency domain on the bottom. We can see that it's not a perfect square wave, which is not possible because of the various frequencies that the ENSCOPE generates to approximate a square wave to the best of its ability. The same principle applies to the triangle wave, however the ENSCOPE needs a much fewer combination of sines and cosines to estimate the square wave as compared to the triangle wave.